Hi everyone, in this video we are going to look at the difference between KSP and solubility. So solubility is the amount of this substance that can dissolve per dm cube of solution. Whereas for KSP, it is a benchmark value, right, for at a certain temperature where it tells you the equilibrium constant of this solubility equilibrium. So I can actually draw a parallel to what we have learned previously, your K, where you have Ka, Kb, Kw, Kp, and Kc. So this is just another solubility equilibrium. So just like any other equilibrium constants, it is a very good benchmark. It is actually a constant at a constant temperature. Whereas for solubility, it is affected by many other factors, including an effect called the common ion effect. So typically, the KSP and solubility has this special relationship that a lot of students will know how to derive. So let's start with a certain amount of solid that is dissolved. So we have an initial amount of 0 when we first add this piece of solid, right, into water. So it hasn't started dissolving yet. It will be 0 and 0 over here. And since this is a solid, I'm not interested in what happens here. So as it dissolves, I will get plus x here. Alright, some of it, I will have some Pb2 plus, and I will have plus 2x of Cl minus. And all I have at the end is x and 2x here. And KSP basically is Pb2 plus multiplied by Cl minus squared. And we do not include the PbCl2 because it's a heterogeneous equilibrium, so we just choose all the aqueous species together, and this will give us x times 2x squared, and this will give us 4x cubed. So for a lot of students, this is what they can derive, but what they fail to understand is that if there is a situation where there's a common ion effect, let's say for example in a separate case, alright, what I have is I throw this PbCl2 into a solution with sodium chloride present, and this is 0.1 molar of sodium chloride. So what you would say is that it started off with 0.1 here. Alright, I will have plus x plus 2x because my solid starts dissolving, and I will get x and 0.1 plus 2x over here. So if I were to substitute all these values back into the KSP expression, I should be able to get this instead. And because the dissociation or the dissolution of this PbCl2 is so small, alright, we usually take this as negligible. So it will just look like x times 0.1 squared. So many students will actually get confused by this portion because they are very used to finding KSP from just x and 2x over here, and they usually find it as 4x cubed. So when there is a common ion effect, take note, please draw the whole ice table out, and it will help you to find out the solubility, the correct solubility and the KSP. So what is the actual solubility with the common ion effect? We want to look at the species here that have the same coefficient as this value here. Alright, so since this is 1 and this is 1, then the solubility is actually x in this case. Alright, but what if everything else is not 1? You just have to normalize it and divide by a certain factor such that the value becomes 1 over here. Alright, so that is the difference between solubility and KSP.